Hello viewers, we are going to look at differentiation of log functions, okay? And so we've been given that if x raised to power y minus exponent x minus y, okay, if x raised to power y equal to exponent x minus y, we're asked to show that the y, the x, is equal to log x divided by log x plus 1 raised to the power of 2. So we have solution. So we write out the question. We have that x raised to power y equal to exponent x minus y. To solve this, we have to introduce log to both sides of the equation. So introducing log to both sides of the equation. So when we introduce log to both sides of the equation, we are going to have log x raised to power y equal to log exponent x raised to power exponent x minus y. And so at this point we know that log will cancel exponent, and so we are left with log x raised to power y equal to x minus y. And so from the law of logarithm, we can move this power to this other side so that we have it to be log y log x equal to x minus y. And so we can move y to this other side. We can exchange the equation, either we take x down or we move y to this other side of the equation. So when we do that, we are going to have y log x plus y. Y is plus because it is negative. So when it crosses the sign of equality, it becomes positive. So this will be equal to x. Okay. Now, if we look at this expression, y log x plus y is common, so we factorize. So I say factorizing the left hand side of the equation. So when we factorize the left hand side of the equation, we're going to have y into, if we take out y here, we are going to be left with log x, and if we take out y here, we are going to be left with 1 equal to x, such that if you say y times log x will give you y log x, and y times 1 will give you y. And so we have to divide both sides by, since we want y to stand alone, we divide both sides by log x plus 1. So divide both sides by log x plus 1. Let's put it in bracket. So when we implement this mathematical statement, we are going to have y into log x plus 1 divided by log x plus 1 equal to x all over log x plus 1. Okay, and so when we cancel this out, we are going to be left with y equal to x all over log x plus 1. So at this point, we know that we have x over log x plus 1. This, for us to proceed from this point, we have to apply the quotient rule of differentiation. To proceed, we have to apply the quotient rule of differentiation, because this over this, we can use quotient rule. So applying quotient rule differentiation. Applying quotient rule of differentiation. We know that for quotient rule of differentiation, the y, the x equal to v, the u, the x minus u, the v. The x as the quotient rule divided by v squared. Okay? And so from our question, our x, say let u equal to x and let v equal to log x plus 1. And so since we've been able to have u and v, we also need to have du dx and dv dx. And so to have du dx, we differentiate u with respect to x here, so that we have du dx here will be equal to, when you differentiate x, it is 1. And then to have dv dx, we differentiate v with respect to x here. And so we have dv dx will be equal to, when you differentiate log x, to give you 1 over x. When you differentiate 1 to be 0. So when you have dv dx will be 1 over x. And so since we've gotten the value for v, and we've also gotten the value for du dx, gotten the value for u, and we've gotten the value for dv dx, can now substitute those values into this equation to find our dy dx. So our dy dx will be equal to, what's the value of our v? This. So write it out here. Log x plus 1. Put it in bracket. Alright, this place will be too small for it. Let's do it here. So our dy dx will be equal to, the value of v is log x plus 1, so we bring it here, so we have log x plus 1, place it in bracket, into, and du dx is 1, so we put 1 there, minus, into, our u is x, so we put x, we are substituting into this equation, and our dv dx is 1 over x, so we have 1 over x. We are done with the numerator. We divide it, and our denominator is just v squared, and this is the value of v, so we are going to write it and then raise it to power 2. So we have log x plus 1, or raised to the power of 2. Okay, x can cancel out here 1, and this will be 1. And dy dx will be equal to, we use this 1 to open this bracket, so that if we say 1 times log x, that will give us log x. And if we say 1 times, if we say 1 times 1 plus 1 times 1 will give us 1. Okay? If we say 1 times 1, it will give us 1. And then at this point, because we have 1 times 1 here, 1 divided by 1, we have minus 1. That is, x cancel out x here is 1. So 1 times 1 here is 1. Divided by 1 here, so we have 1. Divided by log x plus 1 all squared. And so that we know that plus 1 minus 1 is 0. And so our dy dx will be equal to log x over bracket of log x plus 1 all squared. And so looking at it, we've been able to prove that x raised power y equal to exponent x minus y. That the dy over dx of this will be log x all over x plus 1 raised to power 2. So we've been able to show that correctly. Thank you.